All right, hello again, everyone. This is Mr. Laxton talking through the 8.1 through 8.4 practice quiz that we got here. So, again, make sure you subscribe to me on YouTube. I think last time I checked, I was at about 13 subscribers, so I'm making a pretty big deal about this YouTube world. So, get me out there. All right, so here we go. First one here, looking at asking if this is growth or decay. And for this one, we have to look at that B value right there. So we look at that 8 sevenths and say, hey, is 8 sevenths greater than 1 or less than 1? And 8 sevenths is greater than 1, so that tells us that we have growth here for this one. So again, look at that B value, see if you have growth or decay. All right, looking at the second one, we just have to explain how this graph of g of x can be obtained by this parent function f of x. So we have this parent function here, okay? So all you have to do really here is just look and find out what your h and what your k is. So if we look here, my h is going to be positive 1, the opposite of what it looks like, and my k is going to be negative 3, actually what it looks like. So my h moves my graph right and left, and my k moves up and down. So this guy moves right 1 and down, not up, down 3 because it's negative there. All right, so just tell me how that guy moves. That's all you got to say. All right, for number 3, looking at that guy, you have to tell me what the parent function is. So the parent function is just these guys here that I squared in without the h and without the k. These are what we graph first. So your parent function here is y equals 6, 1/2 to the x. No minus 3 and no 2. Just your parent function there. All right. Looking at number 4, I asked you if you invest $1,000 at 3.8% compounded monthly there, what will your investment be worth in 5 years? So if we look at this guy, this 1,000 is going to be my P, my initial amount. This 3.8 is going to be my rate. Monthly means that it happens that would be quarterly, excuse me. Monthly happens 12 times per year, so that's why we're going to have 12 there for my N, and my T is going to be 5 years. All right, so I give you the equation. You have to just plug it in and go here. So we get A equals, my P is 1,000. I have 1 plus 0.038. Don't forget to move that decimal place 2 places. Over 12 raised to the 12 times 5 here for my time. All right. So again, now we just have to go through and put this in your calculator. I would do this first at 0.038 divided by 12, then add the 1, then raise it to that 60th power, and then multiply by 1,000. So if you get here, you should get your A is equal to approximately $1,208.89. All right, so make sure you know how to put that in your calculator, get that answer correctly. All right, number 5 is looking, you're buying a new house that is worth $100,000. That house appreciates at a rate of 8% per year. What will the value of that house be in 2 years? So we looked at 1,000 is going to be my C. Appreciates means that we're going to have growth here for this guy. All right, growth. This 8% is my rate, and we have a time of 2 years. So if I go through and plug these guys in, I get y equals 100,000. And 1 plus, okay, we're going to have plus because it's going to be growth. We have 1 plus my r, which is 0.08, and my time, which is 2. So again, if you plug all this in your calculator correctly, you should get that your house is worth $116,000 and 640 here. All right, so that's what you should get for your final answer for that house. All right, moving on to number 6, we have to find the value of e to the 4, okay? This one's just as simple as putting this guy into your calculator. So you put e raised to the 4 in your calculator, and you get 54.598. Okay, that rounds to the 3 decimals there for that one. Just as simple as putting in your calculator. Number 7, we're looking at moving this into the exponential form. So we talked about a lot in class how this guy moves from logs to exponential. Okay, so in exponential, that base is always my first number. So I have 2 raised to my answer, whatever that is after the equal sign. So 2 to the 5th is equal to that last number that I have left is 32. So 2 to the 5th is 32, so you know that we got it. All right, so this one, number 8, goes backwards the other way. We got to write this in the logarithmic form. Okay, so again, this b goes into my base of that log. So I have log of 4, okay, so log base 4. And then now you have to go through here and put in that 64. My answer goes there. And then that x is what I raise it to, so that is my answer. So we have 4 to the x equals 64. All right, you don't have to solve it here. 4 to the 3rd is 64, but I just ask you to put it in logarithmic form. All right, number 9, look at number 9. We have to evaluate this log here. So I'm going to equal this guy to x. Okay, so if we go through here and we look at putting this guy in exponential form, that base goes first, and then I raise it to whatever is on that equal sign, so that's my x, and then I have that guy equal to 1 over 16. Okay, so I like to ask myself, 4 to what power gives me 16? So I know that 4 to the 2nd power gives me 16. I keep hitting the button over here, so I know that x equals 2, but since this is in the fraction, that turns into a negative because that guy goes to the basement and becomes 4 to the 2nd in the basement. So you should get x equals negative 2 for that one. All right, so going on to number 10, I ask you, these are the graphing ones, 10, 11, and 12. So these are the ones that are a little bit trickier, okay, that you got to find here. All right, so for number 10, I always like to square in that parent function first. So I get y equals e to the x here. Okay, so I already have these x values for you, that negative 2, negative 1, 0, 1, and 2. All right, so the log, these e ones is just as easy as plugging these guys into your calculator. Okay, so if we look here, if we plug in e to the 0 power, okay, anything to the 0 power is 1, so we get 1 out there. Okay, now we plug in e to the first. Okay, e to the first is just e itself, so which is 2.71828 and so on. So I could just say that's 2.7-ish. Okay, and if I plug in e to the negative 1, you can just put that guy into your calculator and you get 0.37. Okay, so you get 0.37 there. So if I graph these guys, I go negative 1, 0.37, I go 0, 1, and then I go 1, 2.7. All right, so if I look here, this graph is going to come all the way in from up here, and it's going to get really, really, really close, but not go past that 0 line. Okay, make sure it doesn't go past that guy. That's important. Okay, so now we have to look and find out what my h and my k is. So my h is equal to 3 here, and my k is equal to negative 3. So that guy is going to move my graph to the right 3 and down 3. So every single one of these points, I got to go 1, 2, 3, and down 3, 1, 2, 3. Okay. This point right here, I go right 3, down 3. This point right here, I go right 3, 1, 2, 3, down 3, 1, 2, 3. Okay, so I know that since my graph moved down 3, that my graph is going to get really, really close to that negative 3, but not go past it. So if I graph that guy, my line isn't completely straight there, but you get the gist. So that line should get really, really close to that negative 3. So that is my final there. All right, so now if I look at my domain and my range, my domain for e's is always all reals. My x's span the whole thing. And now my range is that my y has to be greater than negative 3. And my horizontal asymptote is kind of the same as that range. It's just equals instead of greater than. So we get y equals negative 3 is my horizontal asymptote. Nothing goes past that. So now if I look at number 11 going on here, I look at just that parent function, that y equals 8 1/2 to the x. Wow, it is windy out there. I don't know if you guys can hear that. It's blowing through my window here. All right, but we have this parent function y equals 8 1/2 to the x. All right, so now I just go through here and plug these guys in. I like to use 0, 1, and 2 for these guys. So if I plug in 0, I get y equals 8 1/2 to the 0. So I know that 1/2 to the 0 is 1 times 8 is 8. So I get 0, 8 for that one. If I plug in 1, I get y equals 8 1/2 to the first. Okay, 1/2 to the first is 1/2 times 8 is 4. Okay, if I plug in 2, a little bit more difficult here, I get y equals 8 to the 1/2 to the second. Okay, 1/2 to the second is 1/2 times 1/2, which is 1/4. All right, times 8 is going to be 2. So I should get 2, 2 for that one. All right, so if I graph this guy, I get 0, 8. All right, I get 1, 4, 1, 2, 3, 4, and I get 2, 2. So if I find that origin there, I go 2, 2. So this graph comes up from right here, gets really, really close to that line y equals 0. All right, so that is just my parent function there. I got to make sure that I got to move this, my h and my k. So my h for this guy is -2. My k is also -2. So this guy I know has to move left 2 and down 2. So each one of these points, I go left 2, 1, 2, down 2, 1, 2, left 2, down 2, left 2, down 2. So this graph is going to come all the way in from up here, and it's going to get really, really close to that line y equals -2, because everything moved down 2 spots here. So it should get down to that -2. So that is why my domain, again, is all reals. My range is y is greater than -2. And my horizontal asymptote is y is equal to -2, because nothing goes past that line y equals -2. All right, the last one here, we have number 12. So I'm looking at this one. This is a log function. So I'm again going to square in my parent function, anything without that h and the k. So I have log base 4 of x. Okay, when I always like to do this, I always like to start by writing this as an exponent. So this is 4 to the y equals x. So I already have here that you plug in your y's here first instead of my x's. So if I plug in these guys, 4 to the 0 power is 1. 4 to the first power is 4. 4 to the -1 is 1/4. All right. So if I look here, I can go through and graph these guys. Make sure that you're graphing these points as 1/4, comma, -1. Don't graph -1, comma, 1/4. Make sure you're graphing this guy. So I'm going to point out my origin here with just that blue dot, because it's hard for me to see it. Now I go 1/4 down 1. So that guy's right there. All right. Here I go 1, 0. And then I go 4, 1. So 1, 2, 3, 4, 1. So I know that this parent graph comes in through here. Oh, that did not hit it. So let's take a retry at that one. All right, so I'm going to regraph those points. I get 1/4, -1, and I get 1, 0. So this graph comes in, hits those two, and gets really, really close to that 0, but shouldn't go past it. All right, so now I have to move that with my h and my k. So I look that my h is going to be the opposite of what it looks like. So it's -2, so it pops out as 2. And my k is -1. All right, so everything's got to move right 2 and down 1 here for this guy. So everything moves right 2, 1, 2, down 1. All right, right 2, 1, 2, down 1. All right, right 2, down 1, 1, 2, down 1. Okay, so this guy, and I was not very close on my dot for this one, this guy has to move right 2, down 1, should be right there. Okay, so my graph should come in through these red guys, should get really, really, really close to that x equals 2 line, but not go past it. So it moved right 2, so I got to make sure that it doesn't go past that 2 line. All right, so now if I look, my domain is not all reals for this one. My domain is x is greater than 2 because all my x values are greater than that line x equals 2. My vertical asymptote is x equals 2. And now for my logs, my range is all reals. All right, so that is me talking through these answers through these practice quiz. If you have any more questions, please come find me sometime and ask those, okay? The graphing on this back can get a little bit tricky with how those guys move, so come find me. We'll talk about those. Other than that, be ready for the quiz, and you're going to do great.